Hello everyone, this is Cole Dobbins Spec and I'm here with my Sprint 4 overview for the Radar coding project. Radar is a team for penetration testers to collaborate while doing security assessments of computer networks. So live syncing of information to ensure the team is as productive as possible. So this is the issue tracker in GitHub. The main highlights of this sprint were the addition of configuration files. That way you don't always have to run the program with the same arguments, but you can then store them in a configuration file and then change it as you need. I also added a distributed command queue, and what that means is that the team lead can then actually send commands to the server that are stored. And then whenever clients are free and they're not busy, they'll ask the server if a command's available. And if a command's available, the server will send it to them. And then their client can execute that in the background and then sync the results with the server to ensure that work is being done in the background continuously. So that way you can work as quickly as possible. In Sprint 5, which is the final sprint for IST 361, I'm going to do a bit of tweaking and finalizing a few different things. One thing I really want to get done is switch the API that's being used to be more secure and use cookie-based authentication. So let's hop into the user-facing demo. This is how you would run the client before. The -s argument would point it to the Radar server that's running. So if I go ahead and execute that, it'll connect to the server and then ask me which mission I want to join. And that's cool and all, but if I don't want to type in the -s option every time I run it, now I can hop over to a text editor. I'm just going to open up PyCharm here, and I can actually edit the server settings in the configuration file. So I can change the host to be the same IP address I just typed in. And while I'm also here, I'm just going to set the client's watcher to 5 seconds. And I'll get back to that later. But now if I want to run it, I can just say Python and then client. Hit enter, and it'll automatically connect to the server that I told it to in the configuration. So I'm just going to create a new mission here. And now I can run commands just like I did before. So I can map localhost, that runs, everything is good on that. But in the Radar commands, I have an additional command to distribute, and this will take in what I give it and send it to the server. Then the server will just store the command I give it and execute it on the first available client. So if you imagine that there might be multiple team members connected to a server, just whichever team member is free, their client will execute that command first. So first things, before I actually run that command, let me read the current information from the targets database collection. You'll see the most recent one is from localhost, which is what I just scanned. If I then run command to distribute an nmap command to scan the server that's running, I'll send that out. When I read from the database, it hasn't executed yet, so it still shows only localhost in here. But then after 5 seconds at the latest, my client will have checked the server, found that there was a command in the queue, downloaded it, and then executed that command. So if I rerun the exact same command here, you'll see now it does show up with that information because that command was executed in the background without me having to manually execute it. So it does the exact same thing where it scans the running services on the server and then runs the playbooks and parsing automation that's specified. So it found that this was vulnerable to anonymous FTP login, and then because the playbooks are recursive, it then checks to see what are the contents of that FTP server, but it could do anything else as long as there is a playbook for it. So that's how the distributed commands work in a nutshell. Not too much else has changed with how you would use Radar. It's a lot of stuff in the background for this sprint. So hopping over to the code walkthrough. This is the client configuration file. You can change a lot about how it connects to the server here. If you're running it with HTTPS or the insecure HTTP, you can change how it verifies that here. And you can also specify custom paths to the parser rules and playbook rules if those are stored in another location. The way those work is in the client, you have your command line arguments like the -s option I showed earlier. And what it does is it tries to load the configuration file, and then it parses those command line arguments. So here is a little if statement that if the server argument was specified, it then overwrites the value in the configuration file with what was manually specified. It does this for every option, and then at the end it verifies the configuration file just to make sure that everything that's required for the client is specified and that there's nothing missing from the configuration. The client's configuration is managed by the client configuration manager. This is actually using the singleton design pattern, Python's implementation of it. So how this works here is it takes in the path to the configuration file and then uses a parser on it. And then it's going to take this configuration file and then turn it into a JSON representation of it. And then you can use the JSON data however you would want, but it contains all the data from the configuration file. I'm using a singleton pattern here because multiple classes need to know what the configuration is. So this is a way to prevent them from getting different information if they're not like sharing the same client configuration manager object. This way, every time they try to instantiate a new configuration manager, it gives them the same one, ensuring that the configuration is consistent. And the way that I am running the distributed commands is with this class here, the distributed watcher. And what it does is it starts a new thread that runs in the background. So the thread allows it to run its own code independent of the main code, so doing multiple things simultaneously. And this is just running in the background continuously. It sends a request to the server to see if there's a distributed command available. If there is not, it's just going to then wait for however many seconds I told it to, or that's in the configuration file. If there is a command, it then executes it, makes sure it completed correctly, and then parses it, and then runs playbooks on it. So this is similar to how the client behaved before. The only difference is that it's silent and it all happens in the background. And then once everything has been parsed and automated, it then syncs all that information to the database and then runs again. If there wasn't a command available, it'll wait before executing again. So this was done because, if your client just executed a command successfully, then that means that it's free to execute another command. So that's why it runs again without waiting if it's successfully finished. And how the server handles the distributed commands is just by adding a few more routes to the API. So you have to be a super user, which would be like a team lead, in order to add these commands, just because it's pretty powerful. You essentially get to execute commands on other computers without too much processing for security. So what it does is it takes in the command and just adds it to a list that's stored in the server. This is non-persistent, which means that if the server shuts down, the command queue is empty. I did that for security reasons because most commands you would distribute, you can always redo them, but you don't want the server to have commands in its queue that's causing it to crash or do other weird behavior like that. And then whenever you get the distributed command, if there is something in the queue, it removes the first element of it and returns it. And this is handled in such a way that multiple clients wouldn't be getting the same data from the server, or they wouldn't be running the exact same command due to a error in that. So that's the overview of my sprint. I do have more issues on my GitHub that aren't assigned to a sprint yet, or sprint 5 rather. So I might change around that sprint depending on how I'm feeling at the moment. So sprint 5 may change, but I definitely want to get the correct authorization working for the API. All right, thanks for watching the video. If you have any questions, check out my GitHub and my previous videos as well.